In this video, we're going to be going over how to solve quadratic equations by completing the square. Before we start solving by completing the square, I want to go over what it means to complete the square. So on example 1, it says what term must be added to x squared minus 10x to complete the square. Well, if you look down here, we have a box, right? And we want this shape to be a square and not a rectangle. Remember, the difference between a square and a rectangle is that all four sides are the same length. So our first term, x squared, is going to go in the first box. And because I want this to be a square and not a rectangle, I need to cut this second term in half. Negative 10x divided by 2 is negative 5x. The reason why we're cutting it in half is that we are splitting this term into these two boxes. We want this side length to be the same as this side length. That way it will be a square and not a rectangle. The greatest common factor of my top row is x. The greatest common factor of my left column is x. X times what number would give me a negative 5x? Well, that would be negative 5. X times what number would give me negative 5x? Negative 5. We can now see that this side length is x minus 5 and this side length is x minus 5. So we have made a square because all four sides are the same. But now we want to complete this square by finding the missing number that goes in this box. So we are literally completing this square. To figure this out, we're going to do negative 5 times negative 5. And that's going to give me 25. So what term must be added to x squared minus 10x to complete the square? The answer is 25. So then we would have x squared minus 10x plus 25. Well, I can rewrite this as a perfect square binomial. If we look at our outside edges, we'll see that we've already factored x squared minus 10x plus 25. The factors are x minus 5 times x minus 5. X minus 5 times x minus 5 is the same thing as saying x minus 5 squared. Let's try this again with example 2. It says what term must be added to x squared plus 3x to complete the square? Well, we're going to follow the same exact steps. Step 1 is you need to put the first term in the first box. Again, we want this shape to be a square and not a rectangle. So I am going to need to divide this term into two equal pieces. Well, 3x divided by 2, that's a decimal. And believe it or not, it's actually going to be a lot easier if you leave this as a fraction. So I'm just going to leave it as 3x divided by 2. The greatest common factor in my top row is x. The greatest common factor in my left column is x. X times what number would give me 3x over 2? Well, that would be 3/2. X times what number would give me 3x over 2? Again, that would be 3/2. So now I can see that this side length is the same as this side length. So we do have a square. We want to complete the square. So I want to find this missing piece. To do that, I'm going to multiply 3/2 times 3/2. Remember, to multiply your fractions, you multiply the numerators together and the denominators together. 3 times 3 is 9. And 2 times 2 is 4. So the missing number that completes the square is 9/4. So we have x squared plus 3x plus 9/4. Well, we've just factored this. The factors are x plus 3/2 times x plus 3/2. Oh, not, yeah, 3/2, not 3/4. And I can rewrite this as a perfect square binomial by saying it is x plus 3/2 squared. Now that we know how to complete the square, we are going to solve by completing the square. Your first step when you are solving by completing the square is you want to make sure that your coefficient of x squared is 1. So a needs to be 1. And in this example, it is. The coefficient of x squared is 1. Your next step is you want to get your variables on one side and your constants on the other. So I want x squared and 24x to stay on the left side. And I need to move this 100 to the other side. To undo addition, I'm going to do subtraction. And so I'll have x squared plus 24x equals negative 44. Your next step is to set up your blanks. These blanks represent the number that's going to complete the square. What we do on one side, we must do to the other. Now we are ready to complete the square. Your first term goes in the first box. You want this shape to be a square and not a rectangle. And so in order for that to happen, you need to split this middle term into 2 even pieces. 24x divided by 2 is 12x. The greatest common factor in my top row is x. The greatest common factor on my left column is x. X times what number would give me 12x? Well, that's 12. X times what number would give me 12x? Again, that's 12. Now we are ready to complete this square. We can do that by doing 12 times 12. 12 times 12 is 144. So 144 is that magic number that completes the square. That is the number that I am going to add to both sides of my equation. The right side of my equation, I have x squared plus 24x plus 144. Well, we've just factored that. Those factors are x plus 12 times x plus 12, which is the same thing as saying x plus 12 squared. On the right side of the equation, negative 44 plus 144 is 100. Now I have an equation that I can solve. To undo a square, I'm going to take the square root. The square root undoes the square and leaves me with x plus 12. Whenever we take the square root of a number, it's always plus or minus. The square root of 100 is 10. So from here I have 2 equations that I can solve. I have x plus 12 equals positive 10, and I have x plus 12 equals negative 10. I have one equation for the plus sign, and I have another equation for the minus sign. That's how I'm getting those 2 equations. To solve this first equation, I'll subtract 12 on both sides, and I'll get x equals negative 2. On the second equation, I'll subtract 12 on both sides, and I'll get x equals negative 22. So here I have 2 solutions, and those 2 solutions are negative 2 and negative 22. Let's try this again on example 4. The first thing that you want to do on example 4 is you want to make sure that your a term is 1. So what I'm saying is I want the coefficient of my squared term to be 1. So right now that coefficient is 3. That 3 is not 1. So what I need to do is I need to divide every single term by 3 to make that squared term be 1. So 3 divided by 3 is 1, so that gives me n squared. 12n divided by 3 is 4n. 18 divided by 3 is 6. And 0 divided by 3 is 0. Now that our coefficient of n squared is 1, we want to have our variables on one side and our constant on the other. So I am going to go ahead and I'm going to subtract 6 on both sides. So I'll have n squared plus 4n equals negative 6. Now I am ready to set up the blanks. What I do to one side, I must do to the other. From here, we are ready to complete the square. First term goes in the first box. I want this to be a square and not a rectangle. So I need to divide the second term in half. 4n divided by 2 is 2n. The greatest common factor of the top row is n. The greatest common factor of the left column is n. N times 2 would give me 2n, and n times 2 would give me 2n. The missing value that completes the square is going to be 2 times 2, which is 4. So 4 is the number that I am going to add to both sides of this equation. On the left side of my equation, I have n squared plus 4n plus 4. Well, I've just factored that. That's n plus 2 times n plus 2, which is the same thing as saying n plus 2 squared. Negative 6 plus 4 is negative 2. From here, I want to undo a square. To undo the square, I'm going to take the square root. The square root undoes the square. I'm just going to move over here so I have more room. And I'll have n plus 2 equals, whenever you take the square root of a number, it's always plus or minus. I can simplify the square root of negative 2. I can break this up into the square root of 2 times the square root of negative 1. The square root of 2 doesn't simplify, but the square root of negative 1 is I. So the square root of negative 2 simplifies to plus or minus I square root of 2. From here, I want to get n alone. N is being, or 2 is being added to n. To undo addition, I'll do subtraction. And so I'll have n equals negative 2 plus or minus I square root of 2. These are not like terms, so this is going to be my answer. I do have two solutions here. Those two solutions are n equals negative 2 plus I square root of 2 and n equals negative 2 minus I square root of 2. So again, we have one for the plus sign and one for the minus sign. If you can know that this plus or minus represents two solutions, then you can leave your answer just like this. If it's hard for you to see that this is two solutions, then break it up into its two components. On example 5, before I do anything, I am going to want to get this so that all of the variables are on the left side and my constants are on the other, because right now everything's kind of all scrambled up. So the first thing that I am going to do is I am going to subtract 5b squared on both sides. And I'm going to add 7b to both sides because I know I want all my variables on the left. If you wanted, you could also move that 21 over since you know that that constant's going to need to be on the other side. So to undo addition, I'll do subtraction. So 5b squared, or 6b squared minus 5b squared is 1b squared. Negative 17b plus 7b is negative 10b. 21 minus 21 is 0. Negative 7b plus 7b is 0. 5b squared minus 5b squared is 0. And then I'll have negative 21. My squared term has a coefficient of 1, so there's nothing to divide. So I am ready to set up my blanks. So plus blank, plus blank. What we do to one side, we must do to the other because we have an equation. From here, I am ready to solve by completing the square. So I'm going to go ahead and create that square. First term goes in the first box. I want this box to be a square and not a rectangle. So I need to cut this middle term into two different pieces. Negative 10b divided by 2 is negative 5b. The greatest common factor of my top row is b. The greatest common factor of the left column is b. b times negative 5 would give me negative 5b, and b times negative 5 would give me negative 5b. The missing number that completes the square is negative 5 times negative 5, which is positive 25. So I am going to add 25 to both sides. So on the left side of my equation, I have b squared minus 10b plus 25, and we've just factored that into b minus 5 times b minus 5, which will give us b minus 5 squared. Negative 21 plus 25 is 4. To undo a square, I'm going to take the square root. And so I'll have b minus 5 equals plus or minus 2. From here, I have two equations that I can solve. And I'll write those equations over here. I'll have b minus 5 equals positive 2. And b minus 5 equals negative 2. I have one equation for the plus, positive 2. And I have the other equation for the minus. So that would be the negative 2. So I can solve both of these equations. To undo subtraction, I'll do addition. And I'll have b equals 7. To undo subtraction, I'll do addition. And I'll get b equals 3. So my solutions are 7 and 3. Let's look at example 6. First thing that I want to do is I want to make sure my squared term has a coefficient of 1, and it does. I want to leave my x's on the left side, but I want to move my constants to the right side. So my first step is going to be to subtract 29 on both sides. So I'll have x squared plus 12x is equal to negative 32. Now I am ready to set up my blanks. So plus blank, plus blank. What we do to one side, we must do to the other. Now I am ready to solve by completing the square. First term goes in the first box. I want this to be a square and not a rectangle. So I need to cut this middle term into two even pieces. 12x divided by 2 is 6x. The greatest common factor of my top row is x. The greatest common factor of my left column is x. X times 6 would give me 6x, and x times 6 is 6x. The missing number that completes the square is going to be 6 times 6, which is 36. So 36 is that value that completes the square. On the left side of my equation, I have x squared plus 12x plus 36. I've just factored that. That's x plus 6 times x plus 6, which is the same thing as saying x plus 6 squared. Negative 32 plus 36 is 4. To undo a square, I'm going to take the square root. The square root undoes a square, and that leaves me with x plus 6. And the square root of 4 is plus or minus 2. So from here, I have two equations that I can solve. X plus 6 equals positive 2, and x plus 6 equals negative 2. I have one equation for the plus sign. Oops. Let's get that back pulled up. One equation for the plus sign, so the positive 2, and one equation for the negative sign, so the negative 2. To undo addition, I'll do subtraction. And here I'll get x equals negative 4. To undo addition, I'll do subtraction and get x equals negative 8. So those are my two solutions. On example 7, I can see that I have my x's on one side and my constant on the other. But I notice that the coefficient of my square term is 2. I need the coefficient of my square term to be 1. So I need to divide every term by 2. 2x squared divided by 2 is 1x squared. 6x divided by 2 is 3x. And negative 48 divided by 2 is negative 24. So now we have our variables on one side and our constant on the other. And our square term has a coefficient of 1. So now we are ready to set up our blanks. So plus blank, plus blank. Now we can go ahead and complete the square. First term goes in the first box. We want this shape to be a square and not a rectangle, so I need to cut this into 2 even pieces. Negative 3x divided by 2 would just give me negative 3x over 2. You can just leave it like a fraction like that. The greatest common factor in your top row is x. The greatest common factor of your left column is x. X times negative 3/2 would give you a negative 3/2 x. And x times negative 3/2 would give us negative 3/2 x. Negative 3/2 times negative 3/2 is positive 9/4. Negative 3 times negative 3 is positive 9. 2 times 2 is 4. So I am adding 9/4 to both sides of my equation. So on the left side of my equation, I have x squared minus 3x plus 9/4. And I've just factored that. That gives me x minus 3/2 times x minus 3/2, which is the same thing as saying x minus 3/2 squared. And then remember that your calculator can do fractions for you. If you do not know how to do fractions in your calculator, I can show you in class. But I'm just going to do negative 24 plus 9/4. And if you don't like using your calculator for this, then you can go ahead and just get a common denominator and add that y as well. So this is going to give me negative 87 over 4. To undo a square, I'm going to take the square root. So I am going to have x minus 3/2 is equal to plus or minus. And I'm going to break this up into the square root of 87 divided by the square root of 4 times the square root of negative 1. Let's do the easy stuff first. I know that the square root of 4 is 2. For 87, I know that I can do birthday cake for that. So the smallest prime number that goes into 87 is 3. It goes in 29 times. 29 is a prime number. Oops, that's a 9. And so I don't have any pairs. So the square root of 87 is going to stay that way. The square root of negative 1 is I. So I have plus or minus I square root of 87 divided by 2. I still need to get x alone. So I am going to add 3/2 to both sides. And so I'll have x equals 3/2 and I square root of 87 over 2 are not like terms. because this one has a radical and an I, and this one does not. So I'll just write this in standard form. So I'll have 3/2 plus or minus I square root of 87 over 2. This represents two solutions. Those two solutions are 3/2 plus I square root of 87 over 2 and 3/2 minus I square root of 87 over 2. Those are your solutions.